Okay, this is part 2 of Unit 5D, and we're looking at different types of statistical graphs and extending beyond just our simple two-dimensional graphs, and going into displaying multiple or three-dimensional types of data. So we want to decide whether each of the following statements makes sense, or is clearly true, or if it doesn't make sense, or it clearly is false, and explain our reasoning. So the first one we're looking at is someone says, my bar chart contains more information than yours because my bars are three-dimensional. Okay, as we looked at an example in the first video, that doesn't necessarily mean that's not necessarily true, so this does not make sense, because sometimes the three-dimensional graphs were just for, kind of looks, aesthetics, to make it appear to be more than it really is when it could be shown the same in 2 dimensions. So that's not always the case. Okay, number 11. There's been only a slight rise in our stock price over the past few months, but I wanted to make it look dramatic, so I started to the vertical scale from the lowest price rather than from 0. Okay, this makes sense, and this is actually done all the time. Because if you just give you an example here, if you start at 0 and your stock price is up here, it may just look something like this. But if you tone down your scale and you don't start at 0, so you make it look a little bit different, and they'll usually do a little jag here, and like here's your starting price, you may see things in a little bit different light. So it helps you see those variations a little bit better. So it definitely makes sense, especially in this context of stock price. It helps you see those variations much more clearly when you do not start at 0, rather you start at the lowest point. Okay, 17, we're looking at the following graph. We want to know answer to a couple questions. So first, which group scored higher on the PISA test, which is an international test, and the boys in Canada or girls in South Korea? Estimate their test scores. We don't have to estimate because they're actually given to us, but if we look at the data that we have, you can see that the boys in Canada scored a 523, and the girls in South Korea, if we looked at them, they scored 544. So the better score was the girls from South Korea when we compare those two groups. Okay, part B wants us to compare the boys in Finland. So again, we're looking at Finland. Boys are blue there. So the boys in Finland, they score a 517. When we look at that average score, and then when we compare that to the girls in Japan, they scored a 527. So the girls in Japan would have fared better. So this is just a quick way to look at the graph, and the nice thing that this graph has added is these little numbers here. If those aren't present, then you do have to make some estimations, and usually you just want to estimate those to, in this case our scale is going by 20, so you probably estimate those and there's 5 or so, or 10, just depending on what your data looks like. But that's just one way to look at. Again, it's three-dimensional, but it doesn't give us any more data than it would be in two-dimensional. It just makes it look nicer, more aesthetically pleasing. Okay, this next one we're looking at is what's called volume distortion. So this figure down below depicts the amount of daily oil consumption in millions of barrels in the United States versus Japan from 2015 data. We want to know, does the illustration accurately depict the data, why or why not? So the United States used 19.5 millions of barrels, or million barrels. In 2015, Japan 4.3. Now, this is something that can be used and is used frequently is we distort something to draw your eyes to something and grab your attention, and it may not necessarily be true. So if we look at the height here, this is 19.5, this is 4.3. I mean, those heights, 19.5, 4.3, should be about, the smaller one should be about a fifth of the size. So when we look at the height, that's not bad. The heights look okay, but the volume, notice if we look at kind of the radius or the diameter here, well, circumference that I've drawn, and we compare the two, Japan looks minuscule in comparison. So the heights are there, but the volumes look completely different. Those diameters, they just don't tell a good story, I guess is the best way I could say that. So you have to be very careful when looking at a picture if the person who has put out the picture may be trying to subtly hide something or bring something drastically to your attention, which in this case the eyes are really drawn to the volume. The first one for the United States looks huge, and the Japan looks like this minuscule, teeny little thing. But the heights are actually looking pretty accurate. So those are things to look out for. But definitely not accurate in this description because of those volumes. Okay, the last thing we're going to look at in this video is seasonal effects on schizophrenia. And this is looking at data on the relative risk of schizophrenia among people who were born in different months. So the first part says note that the scale of the vertical axis does not start at 0, so we start at 0.6, kind of like we mentioned in one of our earlier questions. And we want to sketch the same risk curve using an axis that starts at 0 and kind of make some comments on the effects of that change. Now, that was pretty difficult for me to do, so have gone to technology here. And here is what it would look like down here in part A. And notice when we start at 0, and then we go by these increments to get up here so that our graph isn't too big, it takes these bars, these variations, and it shrinks them down. So when we compare it to where we were originally, we have, we've lost a lot of the variation. And so in part A, we would just say that, the variation looks smaller. It appears to be much, much smaller on the bottom when we start at 0. And so that's one thing that can really happen when your scales start at 0, or if they start at a different value. You just have to make sure you look at those scales very closely. Now the next one says each value, so in part B here, each value of the relative risk is shown with dots at its most likely value and with an error bar indicating the range in which the data possibly lies. So this is where it possibly lies, and then this is the best estimate. So possibly lies, and then our best estimate. The study concluded that the risk was significantly associated with the season of birth. And that just means the time, so much more risk in like February and in March because we have higher points here. And we can see that these thresholds go higher. And given the size of those bars, does the claim appear to be justified? One way we can do that is, we can see, is it possible to draw a flat line that passes through all of the error bars? And it's actually very possible to do that. So there's one line right there that goes all the way through and is within that error bar range of every possible date. So in this case, their justification is they're not justified in this because a straight line can be drawn through, meaning it's very possible they could all be exactly the same based off of the information that we're given. So that's a look at bar graphs. So we'll continue in a part 3 using technology using Microsoft Excel to generate some information.